Welcome back, everyone. We're going to continue our conversation on simplifying polynomials. This is just a continuation of simplifying polynomials. We did combining polynomials in order to simplify them. That was adding and subtracting them to simplify them. And then we did multiplying. We multiplied a monomial times a polynomial, and I showed you how to just multiply terms. Today, we're going to extend that into multiplying binomials times binomials. So let's go ahead and get rid of this. Okay, so under your subheading of simplifying polynomials, you should have multiplying polynomials. And then under that subheading, you have a sub-subheading. You had multiply polynomial by polynomial. And then today we're going to do multiply binomial times binomial. This is a subheading of simplifying polynomials, and then these are subheadings of multiplying polynomials. First we did the monomial times a polynomial, now we're going to do binomial times binomial. So I would just put like a squiggly line under that multiplying binomial by binomial, and I've done the same thing on the monomial times polynomial, sorry. Anyway, binomial times binomial, that's just two terms times two terms. And we're going to pick that up in Z8 multiplying two binomials. So this is what it looks like. Here's a two-term, and here's a two-term. This is a binomial, which is a polynomial, and this is a binomial. What we're going to do is we're going to take this whole thing times this whole thing. And again, we use our old friend, distributive property. If you don't know what that is, you need to go back and look at multiplying monomials times polynomials. So this is how we do this. We're going to start with just the a. So just ignore this b, and we're going to pretend like we're multiplying let's just ignore this, okay? Don't do this. I'm just doing it just so you can see it. We're going to pretend like we're multiplying a times c plus a times d. So let's go ahead and do that. Again, don't do that. I'm just doing that so you can see it. We're going to take a times c. Well, positive a times positive c is what? Well, it's just positive ac. Then we're going to take a times d. We've done this before, right? And that's a positive times a positive, so that's also a positive. If the signs were different, it would be negative. Okay, a negative a times a positive d would be a negative ad. So keep that in mind. You'll know it when you see it. Okay, so that's positive a times positive d is just positive ad. All right, now we're going to look at just this now. This time we're going to kind of ignore this one and just look at the b. So on the b, we're going to go ahead and we're going to take a positive b times a positive c. A positive b times a positive c, which is just going to be positive bc. And then finally, I need a different color, go to orange. Okay, then finally I'm going to take positive b times positive d, which gives me positive bd, positive bd. Okay, so that's how you do it. It's just repeated distributive property over and over and over again. I take a times everything out here as many times as I said, then b times as many things I see there. And if there was another letter, I'd take it times everything. So you kind of get the idea. So I want to show you something else. Okay, here it is. A times c plus a times d plus b times c plus b times d. Now, this was our first one. First thing we did was right here. No, I'm sorry, it should have been in red. I'll keep that colors matched up. Took a times c. That was the first thing we did. Okay. And then the second thing we did was we took a times d. That was the second thing we did. Okay, and then the third thing we did was we took b times c. And I'll put a circle around that. Okay. So the third thing we did. And then finally, oh, let me go back there and put that in there. 3. And then finally we did b times d, which is the fourth thing. Okay, I'm going to show you something. Okay, here's what I'm going to show you. First, I want you to see it, and then I want to tell you why it's a bad idea. The very first thing that we did was we took the first term times the first term. First term times the first term. That's an F. Oh, that should be in red. That's an F. Okay. Then we took the outside terms. A and D are the outside terms or the outer terms. Then we took the inside terms, B times C. And then finally, we took the last terms, B and D. And so that's called FOIL. Now, here's the problem with FOIL. FOIL works great if it is a two-term times a two-term. where you run into problems if you ever see something like this: A plus B plus C times D plus E plus F. Of course, you try to do FOIL this and it will not work. That's why I don't recommend FOIL, because I just look at it as repeated distributed property. Oops, let me go ahead and do this. Just show you how it would work. I take A times D plus A times E plus A times F, then B times D plus B times E plus B times F, then C times D to C times E plus C times F. And you can multiply as many polynomials by as many polynomials as you want, and it works. FOIL only works for binomials. So I would get that out of my head if I were you. The reason I showed you is because you're going to hear other people talk about it. So I definitely would not recommend it, but you do know what it means when you hear somebody say, hey, FOIL that. It only works on a binomial times a binomial. It only works on a binomial times a binomial. So I would just get it out of my head. Think repeated distributed property, A times C plus A times B, B times C plus B times D, K times C times K times D, just on and on and on and on. And you can do as many of them as you like. All right, so now the next thing we're going to look at is another example of how this stuff works.